Hi, welcome to Fun Science with Rohini, or probably it is Fun Math. Again, it is an experiment designed by Eratosthenes to identify prime numbers. Wish I learnt it in school, but anyways, I'll tell it to you. It is called the Sieve of Eratosthenes. How do you identify prime numbers before a given number? Let us say you have 120. What are the prime numbers before it? Suppose you have 350. What are the prime numbers before it? To make it easier, I took numbers only up to 65 here. So the demonstration could be easy, will be easy. To identify the prime numbers before 65, first you have to draw a grid and accommodate all the numbers till 65. You can also include 1, but I didn't because 1 is anyways a prime number. So before 65, you draw the grid, write all the numbers down in the grid. And then you start by coloring 2. The prime number after 1 is 2. Prime numbers are those numbers which are divisible by itself or 1. Suppose there is 17. 17 is not divisible by 3 or 4 or 5 or 6 or any other number except 17, and it is also divisible by 1. So by itself or by 1, that's a prime number. So when you are considering or when you want to find out prime numbers before a particular number, here 65, how do you do it? Using Eratosthenes' sieve. You draw a grid, write all the numbers, then begin with the first prime number you have. The 1 is not allowed because 1 can divide everything, so we just don't write it. You begin with the first prime number after 1, and that is 2. And then you start coloring all the multiples of 2. You color all the multiples of 2 and your grid looks something like this. So all the other numbers that are colored here are divisible by 2, so they are not prime numbers. Apart from themselves and 1, they are divisible by 2, which disqualifies them as a prime number. Next, the number that is remaining uncolored in the grid is 3. So you write 3, 2 and 3. The prime numbers, you're listing out the prime numbers here. You write 3. And then you start coloring all the multiples of 3 till the grid looks something like this. And the next uncolored number in the grid, 4 is already colored because it's divisible by 2. It's no longer a prime number. The next uncolored number is 5. So you color 5. You write 5, list of prime numbers. You list it out here along with the list of other prime numbers. And then start coloring all the multiples of 5. And the grid looks something like this. And then the next prime number in the grid that is uncolored is 7. So you color all the multiples of 7 that are already not colored. Already not colored, it's only 49. So you color 49. Next you list out the next prime number, which is 11. But all multiples of 11 are already colored. 33, 22, 44, 55, and we do not go up to 66 because this lists only till 65. Next you move on to 13. You list 13 and see about its multiples. 26, 39, everything is colored. So you move on to, you list the next prime number and then see its multiples, if they are colored or not. Now everything is colored. So you list out all the numbers that are remaining uncolored in the grid, and those uncolored numbers will give you your prime number list before the number 65. Eratosthenes' sieve to identify prime numbers before any number. Just write the first prime number down. You cannot write 1 here because 1 can divide everything. Of course, you can list it if you wish to, but we begin with 2 always. And color all the multiples and then color the next prime number. List out the next prime number and then color all its multiples that are not already colored in multiples of 2. List out the next prime number, color all its multiples that are already not listed in the multiples of 2 and 3. Same way you go on till you get a list of prime numbers before the number 65. And the numbers listed here are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59 and 61. You can do this method of finding out the prime numbers, or you can just do a Google search, and this is what your result will be no matter which method you try. Thank you.